Hey guys, welcome back to my channel. As you know, we're continuing with the same playlist where we're doing exam questions topic wise. Today we're going to do bearings, which is a part of geometry and angles. If you're someone who doesn't know any of the other topics, you can check the playlist above. It has all the topics that come in IGCSE Edexcel Maths A for higher, and you can use this for foundation as well. If you're someone who's doing GCSE Edexcel Maths, Cambridge Maths, or even O-level Maths, you can check out this playlist and develop better understanding of the topics. So without further delay, let's start with the questions. This one says the bearing of Paris from London is 149 degrees. Work out the bearing of London from Paris. So first, let's begin with understanding how we can solve the bearing question. What are the basics of doing those questions? If it says the bearing of something from something, so over here, the bearing of Paris from London. So we draw Paris and London separately. Now, from London, the bearing is 149. That means this is where London is going to be because the bearing is from London. So the angle will be drawn at London and it will start from the north of London in clockwise direction towards the line that connects London with Paris. So this is the line that connects London with Paris, and this is our 149 degrees of bearing of Paris from London. We're asking us to work out the bearing of London from Paris. So bearing of London from Paris is, now this is the north of Paris. We start measuring the bearing from the north in clockwise direction to the line that connects London with Paris. So this is the bearing of London from Paris. Now, a very important thing you need to remember for this is that the north of both the points that you're talking about, like when you're trying to find the bearing, it's between 2 points. And when you're finding the bearing between 2 points, the north of one point and the other point are going to be parallel. They're never going to meet. So as you can see, the north of London is parallel to the north of Paris. So if two lines are parallel, next thing you need to remember is that in parallel lines, alternate angles are equal. This angle is alternate to this angle. So this is also 149 degrees. So if this is 149 and this is also 149, and we know half a circle is 180 degrees. So this is 180. So your bearing of London from Paris is going to be 180 degrees plus 149 degrees, which gives us 329 degrees. That's your answer. So to summarize the entire topic for bearings, your bearing is always measured from the north. It's always measured in clockwise direction. It's always written as a 3-digit number. Let's say we had 29 as the bearing. So you would write 29 as 029, not just 29. It will always be a 3-digit number. Other than that, when it says the bearing of, let's in this case, Paris from London, so you draw the angle at the place where the bearing is measured from. So 149 degrees drawn at London gives us this. So this is the position for Paris. So these are the main things you need to know for bearing. And if you understand these things, then you will be easily able to solve questions for bearings. In this question says the scale drawing shows the position of hall and the position of a library. A post box is 140 meters from the library on a bearing of 220 degrees. Show the position of the post box on the scale drawing, mark the position of the cross X and label it P. Now the scale says that 1 centimeter represents 20 meters, which means 140 divided by 20 will equal to 7. So we draw a line of 7 centimeters from the post box towards the library. Now the post box is 140 meters from the library and at a bearing of 220. So 220 means it's going to come in the third quadrant, which means it's going to be on this side. So using your ruler, you will draw a 7 centimeters line. You won't draw it roughly like me. You will use the ruler once again. And then this will be your position X for the post box because this is your 220 degrees. And for this, you can measure the angle using a protractor. put it over here, library, and then measure a 220 angle. This is 180 till this straight line, the horizontal line. And then, 220 minus 180 is 40. So this angle is 40 degrees. So you draw a line at 40 degrees from this horizontal line. You'll draw a rough horizontal line extending the north and draw a 90 and draw 40-degree angles. And then this complete would be 220. So this is how you label your post box on the diagram. Then use your scale drawing to find the real distance in meters of the hall from the post box. For that, using your ruler, you will measure this line, and whatever distance you get, you will multiply it by 20. Because this distance you're getting, that's going to be in centimeters. So to convert it into meters, you have to times it by 20 to get the real answer. Then says the bearing of the hall from the post box. So that's this over here. So for that, bearing of the hall from the post box, you draw your north at the post box. We know this is 40 degrees, which means this is also going to be 40 degrees. This is the bearing that they're asking for. So what we will do is, using our protractor, we're going to measure this angle over here. And whatever this angle is, it's going to be the same over here. So to find the bearing, we'll add 180 to this angle over here. Whatever this angle is, that's going to be the same over here. So we add this to this. Let me call this x. So 180 plus x, whatever this is, that would give you the complete bearing of the hall from the post box. So for this question, you need your protractor, you need your ruler. You cannot do this freehand. You cannot assume what the value is going to be. You need to measure it accurately, and then you will get your marks. Then the next question says, a boat sails from point X to point Y and then to point Z. Y is on a bearing of 280 degrees from X. Z is on a bearing of 220 degrees from Y. The distance from X to Y is 3.5 kilometers. The distance from Y to Z is 6 kilometers. Work out the bearing of Z from X. So let's first sketch the diagram for this. X is on a bearing of 280 from Y. So let's first begin with sketching the diagram. So if Y is on a bearing of 280 degrees from X, that means Y is going to be in the fourth quadrant of X. So that's going to be somewhere over here. That's where Y is going to be. So this is your Y, this is your X. This is the north of X, this is the north of Y. This entire is 280 degrees. Then it says Z is on a bearing of 220 from Y. So 220 from Y means it's going to be in the third quadrant of Y. Because this entire is 220. So we draw the position of Z. So now we connect the two because we have to find the bearing of Z from X. So first, let's begin with finding the internal angles of the triangle. I label the distances as well. X to Y is 3.5 and Y to Z is 6. So over here, if we notice, this angle is alternate to this one, which means we can easily find that angle. That's going to be 280 minus 180, which is 100 degrees, which means this is also going to be 100 degrees. So now we can easily find this angle, which is inside the triangle. So that's angle Z, Y, X. X, that's going to be 220 minus 100, which is 120 degrees. So we have that covered. So this is 120. So as you can see, we have two lengths in the angle between them. So we can use this to figure out the third length, and then use that to find one of the missing angles to figure out the bearing. And for this, we'll use the cosine rule because cosine rule is only applicable when you're trying to find the third length. And the condition is that we need two lengths and the angle between them. If all three lengths are given, then you can use the cosine rule to find a missing angle. So that's going to be xc squared equals to 6 squared plus 3.5 squared minus 2 times 6 times 3.5 times cos of 120. We plug this in the calculator, 8.32 kilometers. So now that we have the third length, we can use sine rule to figure out the angles. So we're looking for the bearing of z from x, which means we need this angle over here. Because once we have this angle, we can subtract that from 280, and that would give us the bearing of z from x. So the sine rule is going to be, let's call this theta. Sine theta over 6 equals to sine of 120 divided by 8.32. So it's going to be sine theta equals to 6 times sine 120 divided by 8.32. So sine theta is equal to 0.6245. Take sine inverse of that. Clearly, I've used all the space for my diagram. So sine inverse of 0.6245, and that's 38.65. Okay, so this angle is 38.65 degrees. So for the bearing, I'm just going to write it over here. We will do 280 minus 38.65, which equals 241.35 degrees. We want the answer correct to one decimal place, so 241.4. That is your final answer. The next question says a diagram shows the positions of three ships A, B, and C. Ship B is in the north of ship A. The bearing of ship C from ship A is 120 degrees. Calculate the bearing of ship C from ship B. Give your answer correct to the nearest degree. So it's very similar to the question that we did previously, but in this case, they've given us the diagram. So using the diagram, first I'm going to find the length of BC. And since you can see that we have two lengths and the angle between them, so we will be using the cosine rule. So BC squared equals to 150 squared plus 275 squared minus 2 times 150 times 275 times cos of 120. That's going to give us BC squared will equal to 139,375. Then we will square root both sides and BC would equal to 373.33 meters. So now that we have the third length, we can use that to find the angle, and we can find the angle using the sine rule. So we're trying to find the bearing of ship C from B. So that means we need to first figure out this angle so that we can use that to find the bearing. So for that, it will be theta over here. So sine theta divided by 275 equals to sine of 120 divided by 373.33. Cross multiply, sine theta equals to 275 times sine of 120 divided by 373.33. That's going to give us 0.6379. Take sine inverse of that. And that's 39.63 degrees. So this angle is 39.63 degrees. For the bearing of ship C from B, that's this. So our bearing is going to be 180 minus 39.63, which equals 219.63. We want the bearing correct to the nearest degree, which is going to be 220 degrees. That is your answer. So you must have realized that sometimes they can give you a very basic bearing question, which is the one that we did initially. And other times they can give you a bearing question mixed with sine and cosine rule. So you need to be familiar with the conditions that we require to use the sine rule and cosine rule. And then based on that, you can easily solve your question. Then this one says A, B, and C are 3 points on a horizontal ground. AB is 8.4 meters, BC is 9.2 meters. B is on a bearing of 67 degrees from A and C is on a bearing of 129 degrees from B. Calculate the bearing of A from C, giving your answer correct to the nearest degree. So the pattern seems to be the same. And also, if you notice over here, it's not written 65 alone, it's 067, which I told you in the beginning that the bearing is always written as a 3-digit number, never a 2 or a 1. So let's begin with drawing the diagram first. B is on a bearing of 67 from A. So if A is over here, B is over here in the first quadrant. This is 67. Then C is on a bearing of 129 from B. That's over here. And this line connects A with C. So this is 129. We have the distance of AB, which is 8.4, and BC, which is 9.2. This must remind you of the previous questions as well, because the steps are once again very much the same. We need to first find this angle in the middle over here. So we know if this is 67, this is also going to be 67. And we can easily find this angle by subtracting 129 from 180, which gives us 51. So our total angle ABC is going to be 67 plus 51, which is 118 degrees. Now we know that when we have two lengths in the angle between them, we can use the cosine rule to find the third length, which is going to be AC over here. So AC squared equals to 8.4 squared plus 9.2 squared minus twice of 8.4 and 9.2 times cos of 118. So AC squared equals to 227.76. We'll take the square root on both sides, and AC will equal 15.09 meters. So this is your length of AC. So using the sine rule, I'm going to calculate this angle over here, because once we have this angle above the line, complete angle would be the same as below the line because they're alternate. So I'm going to use this angle to figure out the entire bearing of C from A first, and then use that to find the other bearing. So sine rule once again, and it's going to be theta over here. So sine theta over 9.2 equals to sine of 118 over 15.09. So sine theta is 9.2 times sine of 118 divided by 15.09, which is going to give us sine theta as 0.5383. And then we take sine inverse of it, which is going to give us 32.57 degrees. So now bearing of C from A is 67 plus this angle, 32.57, which is 99.57. So this will also be 99.57 because they're alternate angles. So final answer, bearing of A from C is 99.57 plus 180 degrees because this entire thing is the bearing. All of this till this line. So that's going to give us 279.57 degrees. If your answer correct to the nearest degree, so that's going to be 280 degrees. That is the bearing of A from C. And with that, we're done with the questions for bearings for IGCSE Edexcel Maths A. If you're someone who understood everything, please like and subscribe. And do check out the other videos in the playlist because we're going through all of the exam questions from papers starting from 2018 to 2025. Through this playlist, you will be provided a great division of topic-wise questions for each topic. So this way you can address each weakness step by step and make sure that your preparation is on point.